In this lecture, we'll see what is the basic concept behind thresholding, the role of illumination, and global thresholding. In global thresholding, we'll see the algorithm and how to solve problem on the image. Here f of xy is input image is given with the values 10, 20, 10, 15, 17, 15, 200, 170, 13, 12, 40, 180, 210, 50, 55, 25, 9, 8, 7, 10, 15, 9, 9, 3 and 2. Now just by observing here, we can say that there are two modes are present in this image, that is light object is present on the dark background. Or after observing the histogram of the image, here the histogram is shown below, but actually this is not the histogram of f of xy, but in general if we'll draw the histogram of object present on the background, dark background, we are getting this kind of a histogram. Now L1 on the x-axis, L minus 1, the gray levels, and on the y-axis occurrence of particular gray level is present. So if we'll draw the histogram, we are getting L1 gray level values are belonging to background and L2 gray level values are belonging to object. Now in between these two, a space is there, so we can set any t in between these two. So if we set t is equal to 100, so after thresholding we are getting image is in the form of binary 1 and 0. We'll set the pixel value 1 if f of xy is greater than threshold value, that means 100, and if f of xy is less than threshold value, then we'll set to 0. So after applying this thresholding, we can clear cut differentiate two modes. One is object and another is background. Background is represented by black color and object is represented by white color. Here another example is given. For input image coins, the histogram if we'll draw, we are getting this kind of histogram. Again two modes are present. The lower one is represent background and the upper one represent a object. If we'll set a t is in between these two modes, then we are getting a binary image which is represent in the middle. So the coins now converted to white color and the background will convert it to black color. Here one more example is given. In this case, the two objects are present on the background, but if we'll observe carefully, the object 1 and object 2 gray level values are similar. So if we'll draw the histogram of this kind of image, we are just getting two modes. So there is a space in between two modes. So after that we can set a threshold easily. So after applying threshold, we can clear cut differentiate between the two object and the background. Now if this kind of histogram is given in which two objects are present, but object 1 and object 2 has different gray level values and background is near to black or dark background is present. So L1 is belonging to background, L2 gray level values are belonging to object 1 and L3 gray level values are belonging to object 2. So we have to set here two threshold value. One is in between object 1 and background and T2 is in between object 1 and object 2. So If f of xy is in between t1 and t2, then it is part of object 1. F of xy is greater than t2, then it is part of object 2. And f of xy is less than t1, then it is part of background. Now, based on this discussion, the thresholding may be viewed as an operation that involves the test against the function t of the form t is equal to t of x comma y comma p of xy comma f of xy. So here p of xy is shows local properties, like suppose if we consider average gray level of a neighboring pixel, and depending on that value, if we'll set that threshold value, then it is called as a local property. X and y are the simple coordinates and f of xy is a gray level value. So if my threshold value is just depend on f of xy, means gray level value, it is called as a global thresholding. As we have seen a simple example above, that is global thresholding, because the threshold values are just depend on the gray level values. But if my threshold is depend on gray level values f of xy and it is depend on p of xy, some local value or local property, then it is called as local thresholding. And if thresholding is depend on local value p of xy, gray level value f of xy and coordinates x and y, then it is called as adaptive thresholding. Role of illumination. F of xy is formed as the product of reflectance component r of xy. And illumination component I of xy. The purpose of this section is to use the model to discuss the briefly about the illumination and reflectance on the thresholding, especially on global thresholding. Consider the computer generated reflectance function shown in the figure. Now, by simply observing this image, we can say that this is a bimodal. If we'll draw the histogram of this, we can see the histogram with two modes. We can easily set t threshold value is in between these two modes, and we can apply thresholding on this image. But suppose the reflectance component shown at the right hand side if we multiply the reflectance component with the illumination component, what will be the effect on the histogram? Actually, we will see in this diagram. If this illumination component is drawn here at the right hand side, and if we'll multiply that illumination component with the image, we are getting this kind of image is shown at the lower side. Now if we'll compare this image and this image, these two images are different, because here the second image is multiplied with the illumination factor. Now if we'll draw the histogram of this image, we are getting this kind of histogram. Now if we'll compare the previous histogram and this new histogram, both are different. In previous histogram, we can easily set t and we can apply the thresholding on the input image. But here in this case, the thresholding is not that much simple. So in this way, the illumination effects on the or we can say that if the illumination is not proper, the thresholding is not that much easy. That's why the histogram is so distorted. F of xy is equal to I of xy into R of xy. Because f of xy is a formed as the product of reflectance and the illumination, R of xy and I of xy respectively. So z of xy, I am getting natural logarithm of input image f of xy. It is equal to log of I of xy plus log of R of xy. Log of I of xy represent in I dash of xy and log of R of xy represent in R dash of xy. So z of xy is the addition of I dash of xy plus R dash of xy. Image g of xy is equal to k into I of xy, where k is the constant that depend on the surface and I of xy is the illumination pattern. Then for any image f of xy, where f of xy is equal to what? I of xy into R of xy. If we'll put the value h of xy, we are getting f of xy divided by g of xy. After putting f of xy value into the equation, g of xy divided by I of xy, it is equal to k. So h of xy is equal to R of xy divided by k. Thus, if R of xy can be segmented by using a single threshold value t, then h of xy can be segmented by using a single threshold value t by k. Basic global thresholding. The simplest of all thresholding technique is to partition the image histogram by using single global threshold t. Now here example is given. For input image, we are getting this kind of histogram. So two modes are shown. We can set the histogram and after applying histogram we are getting, after applying thresholding we are getting this kind of image. If we observe first image and second image, the shadow effect is removed and we are getting the output in the form of white color and black color. Here the histogram is shown and after applying threshold value on the histogram, we are getting this kind of image. But suppose if I don't know what is the histogram of input image, then how to apply this global thresholding? So without histogram, how to find threshold value? For that we have a algorithm, that is global thresholding algorithm. Now let us see how to apply this algorithm, how it will work. First of all, select an initial estimate for threshold value t. Take any t, but in general we are taking the average value of the image. Step 2 is segment the image using t. This will produce two groups, G1 and G2. In G1, the gray level values greater than t, and in G2, the gray level values which are less than or equal to t. Step 3 is compute mu1 and mu2. Mu1 is the average gray values of G1 and mu2 is average gray level values of G2. Now compute new threshold value t is equal to half of mu1 plus mu2. And the next step is repeat step 2 through 4 until the difference in t successive iteration is smaller than a predefined parameter t0 or t. When there is a reason to believe that the background of object occupy comparable areas in the image, a good initial value of a t is the average of gray level of the image. When objects are small compared to the area occupied by the background or vice versa, then one group of a pixel will dominate histogram and the average gray level is not as good as the initial choice. A more appropriate initial value of a t in cases such as this is a value midway between the maximum and minimum gray level values. The parameter t0 is used to stop the algorithm after changes become small in terms of the parameters. This is about the algorithm. Now we'll apply this algorithm on input image. Now I have taken the same example f of xy and let us apply global thresholding on this. So I have first of all taken the average value of all this and I set it to first threshold value as t1. So 25 pixels are there. So after finding the average I am getting t1 is equal to 45. So if we'll apply this t1 on the input image, I am getting 6 pixels 200, 170, 180, 210, 50 and 55 above that threshold value and other pixel below the threshold value. That's why these 5 pixels I have written with the red color and the other background pixels are written with the blue color to differentiate. Now from this image I am getting two regions. One is a G1 and another one is G2. Let us consider the background is a G1 and the object is G2. The red color is a G2 and blue color is G1. Now according to algorithm, what we have to do, we have to take the average value from this red color pixel. So I am getting this as a 144 and from background G1 the average value is 13. Now the next step is to find half of mu1 plus mu2. So I am getting new threshold value as a t2 is equal to 79. Now this according to this new threshold value 79, if I'll apply this thresholding on the input image, then I am getting this kind of image. Now there is change in this image and this image because previous threshold value was a 45. That's why 50 and 55 are belonging to G2. Now this 50 and 55 are belonging to background. So only 4 pixels are remaining here with the red color with the G2 and others are a part of background G1. Now again calculate this 79 is not less than the previous value or near to previous value. Then do the same procedure. Apply this T2 on the image and after that I am getting mu1 as a 17 and mu2 is equal to 190. From this mu1 and mu2 value I am getting third threshold value that is a 104. Now again this 104 is not less than or equal to the previous thresholded values. That's why again repeat the same procedure, but after repeating this I am getting the same image after applying 104 on that. That's why I am getting mu1 as 17 and mu2 as 190 again. But this T4 is 104 which is same as that of previous threshold value. That's why my final threshold value is 104. In this way we can apply the global thresholding and this is my final answer. And this is correct answer in which we are getting 4 pixels are belonging to object and the remaining pixels are belonging to background. Thank you.